Okay, in the previous video, we talked about what makes a good abstraction, and then we came up with these 7 points. So right now, we will see how we can implement some of these ideas in a sample question, right? So before we do that, as a reminder, there's something called we learned before called wishful thinking, top-down approach. Pretend you have whatever you need. So this is one key idea when you think about abstraction. When you break down the problem, just assume that you have an existing function to solve that smaller problem, and then just continue breaking down from there. Okay, then later you come back, you start to fill in the functions that you actually need. Okay, so this is when you are starting to write this is not when you're doing the implementation. This is when you are saying, oh, in order to solve this problem, I need this function, so let's just write this function. Just keep it as a placeholder for now, and then we'll come back to write the function later on. All right. So let's look at this taxi example. In Singapore, a few years ago at least, I think the numbers are not updated. The taxi fare is based on distance traveled as follows. If you go for less than 1 km or less, you get your fare is $3. Then subsequently, every 4 meters thereafter or less up to 10 km is 22 cents per 4 meters. And then after that, every 4 meters thereafter or less after 10 km is another 25 cents. Okay, so there are 3 tiers you need to take care of. All right, so this is your problem. Your problem is that you need to write a Python function that computes the travel fare from the distance traveled. Okay, so basically I give you the distance, and then you're supposed to tell me that the fare. Okay, so what do we need to do to solve this problem? Okay, let's approach this step by step. First thing first, we need to formulate the problem. Okay, we need a function. The function needs a name. Okay, so you can pick from a variety of names. You can create your own names, but try to pick one that is appropriate and makes it easy for people, including yourself, to understand what you're doing. Okay, so in this case, let's just call this function taxi fare. Okay, taxi fare is a black box that takes in an argument of distance, and then it will give you the output, the total fare. All right. So let's look at what you would need for this. What data do you need? Where would you get it? And the result should be unambiguous. That means the result should, like, if you run the function on the same number 2 times, 3 times, 4 times, you should give it the same outcome. All right. Then also think about what other abstractions may be useful. Okay. Then ask the same question for each abstraction. Okay. So basically, you're trying to break it down step by step. Okay, after even you find one abstraction, can you find more abstractions to break it down? And then for each abstraction, right, you need to be able to answer these questions. All right. Okay, so how can the result be computed from data? We will use simple examples to try, and then we will strategize them step by step. Then we write our code down, then we refine it. Okay, so let's try. Okay, let's to answer some of these questions first. What to call the function? We call it taxi fare. What data is required? The distance. How to get the data? Use an argument to the function. What's the result? Fare. Okay, we'll get a fare. We'll get an integer in this case, or float. I think it could be a float because the fare was in cents as well. All right, so let's try. Let's look at some basic data. If the first example, if my distance is 800 meters, because it's less than 1,000 meters, the fare will be $3. If my distance is 3,300 meters, I will take $3 because I've traveled 1 km already. Then I'll minus off 3,003 minus 1,000, and then divide by 400, and I'll round up. Round up because remember it's every 4 meters or less. Okay, then take the number, multiply by 22 cents, I get $4.32. The next example is a bit higher one, 14,500 meters. So this one, I will take this fare. Okay, remember the tiering there's a few of them. There's a 22-cent tiering, and then there's a 25-cent tiering. Okay, so same thing, take 14,500 minus away. You need to break it down nicely. So basically this one here, you need to minus off the first 1,000 km, then you minus off 1,000 meters, then minus off the 9,000 meters to form a total of 10,000 meters. Then the remainder will fall under the last price category. Okay, so these are the things we have to do. Okay, so these are some examples. Okay, so let's look at how we can do some pseudocode. Okay, pseudocode here essentially is that we are just writing out the steps, okay, in human readable form. That means it's basically you see some symbols and see English, right? We'll talk a bit more about pseudocode the next time around. Okay, so this was what we got from the previous one. So we basically use the term distance. Okay, then we just, so for here, for case 1 is quite straightforward. Case 2, right, because distance is between 1000 to 10,000 meters, right, I will take the $3 for the first 1000 meters, then I take 0.22 cents multiply by this value here, distance minus 1000, then divide by 400, round up. Okay, then for the next one here, I take 8.06. Okay, how do I get 8.06 over here? Alright, what's this? Okay, this is essentially, right, the maximum value you can get from case 2. Okay, if case 2 is like basically 10,000, okay, if you sub to this function, this steps here, you'll get 8.06 plus, so it's $3 plus whatever that is from this portion here. This will give you 8.06. Okay, yeah, fair for 10 km. All right. Okay, so yep, so we have this function here, math.ceil, that will help us later. All right. Okay, so let's look at this code now. All right, we have a taxi fare, that function that takes in the argument distance, and distance is always in meters. If distance is less than or equals to 1000, just return 3.0. L, if distance is less than or equals to 10,000, return 3.0 plus 0.22, then multiply by ceil, distance by 1000, then divide by 400, etc, etc. So I think these steps here are quite okay. You can, it's basically a if and else blocks. Okay, then you can use some of the test cases that you have obtained beforehand. Okay, you need to test for each of the condition, make sure that it is working correctly. So we use the whatever that we have calculated earlier to go and check. All right, so can this solution be further improved? All right, let's see what we can do to improve this solution. Okay, what if the starting fare is increased? Okay, from $3 to 3.20 cents, which actually is it the current starting fare? I'm not very sure. Okay, what if 400 meters is increased to 300 meters? Can we can our code make these changes or not? Okay, so basically what's happening here is that you have this thing called magic numbers. Okay, let me go back 2 slides to show you what the magic numbers are. Okay, I think actually there are some numbers here that are hard coded, like for example 1000, 0.22, etc. All these are hard coded numbers. Okay, so when you have hard coded constants, right, it's difficult to make changes in future. Okay, what do we mean by that? So numbers are this, right? If you written this function like 2 years ago when the fare was still correct, and then now the fare is updated, right? For you to update this function to make it work correctly, you have to go back into the function and go and hunt for all these numbers, 3.0, 400, and 400, and make the necessary changes. Okay, so that will make it very tedious, and more importantly, right, it's also very prone to error. If you miss out one of the numbers, right, and you run it, it will seemingly work, but the output might not be correct. Okay, so how do we go about avoiding this problem? What we can do is to define two global variables here, because it's we're just talking about this function. So we define two variables here that could be used by the rest of the function. So instead of hard coding 3.0 here, I assign it to a variable called start fare 3.0, and then the stage here I put as 400, so then I can just slash stage over here. So when I want to update this function, it's very easy. I just need to change these values on top, 3.0 and 400. Okay, yeah, but there's also one more here. There's this 8.06 at the bottom. How do you update this? This 8.06, remember, is based on the calculation of using a starting fare of 3.0 and the stage of 400. Okay, so this one is not so simple to remove. Okay, but again, you can try. What I can do is that you can basically just, if you think about it, right, this is just a taxi fare at when the distance is 10,000 meters. So you can basically put this call of the function there, and then that will work as well. Alright, so after we modify this will become this way. Then this one is a new one, the else return taxi fare at 10,000. So now I can see there's something new to you. Within a function, I can also make use of a call to the same function. Okay, so if the code reaches this point here, it will call the same function one more time. Okay, you run this function within this current scope. You run it within. All right. Okay, so right now you can see that we can easily cope with changes. We can change the starting fare to 3.2 and then decrease the block to 300 meters. Alright, so that's how we can work with this. Okay, you can update the numbers very easily. Okay, so yeah, and again we can try to remove, if we want to be really flexible, we can remove all the magic numbers. Okay, so if you go back to the previous slide, you can see that there's still this 0.22, 0.25, and maybe the 1000 and the 10,000 as well. Okay, so I can put a stage 1, stage 2, and then the starting fare, increment 1, increment 2, and block. Okay, and then you can do it this way. Okay, does it make sense? Is it good practice to do it this way? I would say yes and no. Okay, yes, because it removes all the magic numbers. Okay, and then subsequently your code could be updated. Your variables in your code could be updated very easily. However, you need to also consider how regularly you're going to use this function. If it's going to be a once-off function and you're going to be used like once and not going to be used forever, right? Then it might not make so much sense to spend so much time and effort to update all the magic numbers into a variable. Okay, so that's all for LT3b. You can go and complete the questions. After that, you can proceed on to tutorial as well. That's all for functions for now. Thank you.